Hey everybody, Miss Dietrich here. We're taking a look at 8.6, which is on solve multiplication and division equations. And it's very important when you go through the homework to make sure that you classify each of the questions into one of three categories. So what are those three categories? They are questions that have, or equations rather, that have no fractions. The example that they give you for number 1 is just such an example. So it's just straightforward. It's 8 times p equals 96. There are ones where the numerator, or the variable rather, is a numerator. So if we look at, look at number 6, that one's like that. Number 2 is like that. Number 2, number 6 is like that. And also number 10 is like that. All right, and then we have ones where there are fractions. So, for example, number 5 has fractions in it. Number 12 has fractions in it. Number 9 has fractions in it. So the ones that I think are the most challenging are probably the ones in this far right column. So why don't we focus on those first? So as a matter of fact, let's take a look at number 5. So number 5 is 2w, or 2/5 w equals 40. All right, so let's just clone this thing, and we'll move it down here so we can work with it. All right, now what we should be saying to ourselves, what's the opposite of multiplying a variable by 2/5? And the answer to that question is to divide by 2/5. So I want to remind everybody that when you divide by 2/5, that's the same thing as multiplying by the reciprocal. So if we think about the reciprocal of that, that would be 5/2. So that's what we're going to do. We're going to multiply both sides of the equation by this blue value here, which is 5/2. All right, so what happens to the left side? Well, everything sort of cancels out. If we simplify this and divide by 5, aren't we going to get 1? And if we simplify going this way and reduce, aren't we also going to get 1? And isn't 1 times 1, 1? And isn't 1 times 1, 1? And isn't 1 divided by 1, 1? And anytime we multiply 1 times anything, we get the same thing, whether it's 1 times 7 is 7, 1 times a half is a half, 1 times w would be w. So that all ends up being w. So that's all supposed to be mindless stuff. Now over here, when we do the work for this, some people like to stick a 1 underneath that, but we can simplify here. We can take advantage of the fact that 2 is a factor. Here, it goes in once there, and here it goes in twice. And if we do 20 times 5, that would give us 100. And of course, 1 times 1 is 1, and if we simplify that, we're going to get 100. Now, we don't have to sit around and wonder, did we get it right? Because we can do a check. So what does a check look like? We take our answer, remember we got 100, and we substitute it into the original equation. So let's erase all this stuff. And if we substitute in what we got, we have 2/5 times w, and we're saying that w is equal to 100. And we want to make sure that that equals 40. And remember, 100 is the same thing as 100 divided by 1. And if we go ahead and do the work for this, right, we can divide by 5 and get 1, divide by 5 and get 20. And isn't 2 times 20 equal to 40? And isn't 1 times 1 equal to 1? And wouldn't 40 divided by 1 equal 40? So that's a check. That checks. All right, let's take a look at another example that's like that. So we just looked at number 5. Let's look at a few more that are in that category of there are fractions. Why don't we look at number 12? Let me bring that down here, make it bigger. All right, so the first thing you should be saying to yourself, what's the opposite of multiplying a variable by 3/4? And the answer to that question is to divide by 3/4. And what's the same as dividing by 3/4? Multiplying by the reciprocal of that. What's the reciprocal of this? It's times 4/3. So that's what we're going to do. We're going to take this and do it on both sides of the equation. We're going to multiply both sides of the equation by the reciprocal of the coefficient, we call that. So we'll put that over here, and we'll also put it over here to keep the equation balanced. All right, so what you should know is that all of this cancels out. You're supposed to just kind of automatically know that. and we get 1, and 1 times g would be g. And over here, we can take advantage of the fact that we can reduce going this way. 4 is a factor of both this numerator and this denominator. If we divide by 4, we're going to get 1. Divide by 4, we're going to get 2. We can't do anything going this way, so we're ready to go across. 5 times 1 would be 5, and 2 times 3 would be 6. So we end up getting 5 sixths as our solution. Now again, we don't have to sit around and wonder, did we get it right? We're going to take our solution, which I'm just going to write over here so we don't forget, and substitute it in and do what's called a check. So if we substitute in the value, 3/4 times g, which remember for g we got this, should equal this, which is 5/8. We can reduce right here, divide by 3, divide by 3. And if we do 1 times 5, doesn't that equal 5? And if we do 4 times 2, doesn't that equal 8? So the two sides of the equation match, which means that we have what's called a check. It checks. All right, so I think we're in pretty good shape with understanding. We didn't do number 9, but in this case, what would be the opposite of multiplying by 2/3? It would be to divide by 2/3, and that's the same thing as multiplying by 3/2. So you're going to, when you do this one on your own, you're going to multiply both sides of the equation by 3/2. All right, let's take a look at some of the other examples. So let's take a look at the ones that are in the middle here, ones where the variable is a numerator. So if we stop and just think about what these things really mean, sometimes that can help you. So let's look at number 2 first. Number 2 really means z divided by 16 equals 8. So you could write it like this, z divided by 16 equals 8. This is another way to write this expression. Now you have to ask yourself, what's the opposite of dividing a variable by 16? And it would be to multiply by 16. So if we had done it this way, we might show 16 being multiplied on both sides of the equation. But usually math teachers don't like you to set it up this way, because this all would cancel out and you're just doing this. What they would rather you do is to take this and say to yourself, the opposite of divide by 16 is to multiply by 16, and put that on both sides of the equation like this. That's considered better formatting. So the 16s would cancel out, because remember this is the same thing as 16 over 1. That all cancels out, and we're left with z, because z times 1 would be z. And then we just have to find what 16 times 8 is. 16 times 8. We do the algorithm over here. Here we get the 48. 8 times 1 is 8, plus 4 would be 12. So we should be getting 128 for our answer. So again, you don't have to sit around and wonder, did I do it right? You can just take your answer of 128 and substitute it in. So if we substitute it in, remember we got 128, and if we divide that by 16, we're supposed to get 8. Now we can do the algorithm of 128 divided by 16 to make sure that we get 8. And if we do, we already know, right? We already have the work over here. It does equal 8. All right, so in other words, we have a check. 18 equals 18. All right, so let's take a look at another one that's like that. Maybe this one's got decimals in it, so maybe that one should be one that we should look at. We'll do number 6. So let's move all the ones that we did kind of out of the way here. And I think what I'll do this time is, just because the number 6 kind of gets in the way, so I'm just going to take a picture of that without the 6 on it so that's not in our way. Let's try that again. Didn't take. There we go. All right, so what you should be asking yourself is, what does this really mean? It means a divided by 14 equals 6 8/10. Well, what's the opposite of dividing a variable by 14? And you should be saying to yourself, multiply by 14. So good formatting is to show 14 being multiplied on both sides of the equation. All right, now remember 14 is the same thing as 14 over 1, so if that helps you to see that these things cancel out, and that this whole thing is going to equal a. So that's supposed to help you understand that you're really multiplying 6 and 8/10 times 14. So let's use the calculator on this one. 6 and 8/10 times 14. And we get this. We get 95 and 2/10. So we don't have to sit around and wonder, did we get it right? What you do is just substitute in your answer into the place of the variable, substitute it in where the a is, and make sure that it's right. So if we substitute it in, we're doing 95 and 2/10, and we're going to divide that by 14 because that's what that means, and hope that we get the 6 and 8/10. So just in the interest of saving time, I'm going to use the calculator. I'm going to put in the 95 and 2/10, and we're going to divide that by 14 to make sure that we get the 6 and 8/10, and we did. So 6 and 8/10 equals 6 and 8/10, so that's a check. That checks. All right, so ones like this where you have the variable is a numerator, that just quite simply means you're dividing by whatever the denominator is, and the opposite is to multiply by that number. All right, so let's take a look at some of the ones that we left behind. So the ones that we left behind are all ones where there are no fractions. So everything is either whole numbers or decimals. So let's take a look at number 8, because that one can be a little bit intimidating. Let's move this one down here. So that kind of falls under, oops, I can't grab that. Somehow it got locked. Well, let's see if I can hit the undo button and bring it back to where it was. That's better. All right, so that kind of falls into this category, right? Falls into this category. So ones that fall into that category, you're just simply dividing both sides. Let's move it down here so we have some workspace. And we'll clear the other stuff out of the way. So let's move that out of the way, and we can delete that. All right, so with a proper formatting for that, it's first to recognize what's happening here. So b is being multiplied by 3 and 5/10. What's the opposite of multiplying a variable by 3 and 5/10? It's to divide by 3 and 5/10. So anything that's going to be in this left column, you're going to show that by just putting a fraction bar and writing the coefficient underneath both sides of the equation. And then this would simplify. If we simplify that, we get 1, and 1 times b would be b. And then we just need to divide these two things out. So let's use the calculator once again. So you always take the numerator first and pump that into the calculator. So it's 23 and 8/10. And we're dividing that by 3 and 5/10. And we're getting this, 6 and 8/10. Wow, that's familiar. We saw that number before, didn't we? All right, so you don't have to sit around and wonder, did we get it right? You take your answer and you substitute it in, because remember, this means you're multiplying, right? You're multiplying these two things together. We're taking 3 and 5/10 and multiplying it by 6 and 8/10. So let's just do the double check on the calculator. We're taking 3 and 5/10 and multiplying it by 6 and 8/10 to make sure that we get this, which we did. So 23 and 8/10 equals 23 and 8/10. The two sides are a match, which means we have a check. All right, so just to kind of recap, because we're not going to have time to do all of these, what you want to do is the ones like number 7, that kind of falls under that category where you're going to be dividing both sides by the coefficient. What's the coefficient in this case? It's this number right here, 1 and 6/10. Number 3 is like that. So what's the coefficient in this case? For number 3, the coefficient is 3 and 5/10. Well, how do we know that's the coefficient? It's because it's the number that's being multiplied with the variable. So you're going to be dividing both sides of the equation by 3 and 5/10. And that's true for these as well. Number 4 and 11, they also fall into the category of no fractions, and you're just going to use that idea just like number 1 here. Let's move this out of the way so you can see it. Number 1 has that idea of using fraction bar and showing division with the fraction bar. All right, so that pretty much gives you a good summary of the 3 different approaches that you're going to be taking. So again, we have the ones where there are no fractions. We have the ones where the variable is a numerator, and we have ones where there are fractions. So by the way, I should probably mention that if you have ones where the denominator is the variable, so for example, if you had something like I don't know, 7 divided by x equals 21, right? This is not at all the same approach, because in this case, if you did have something like this, then the approach that I think I would recommend is to stick a 1 underneath this and use cross products. So this would end up being 7 equals 21x. And then you would have to divide both sides of the equation by 21. This would cancel out. And really, you're just simplifying 7 over 21. So if we divide by 7, we get 1. Divide by 7, we get 3. So really, the answer to that would be 1/3. So these are different. You're not going to see too many of these in 6th grade math, but you should be aware that there's a big difference between having the numerator be a variable and having the denominator be a variable. Completely different type of problem. All right, so again, and then the third kind are the ones where you have fractions. And you could have, in this case, we just have one of the sides of the equation has a fraction, the other side has a whole number. So either way, it's going to be the same approach, where you're looking for the coefficient and you're asking yourself, what's the reciprocal of that, and multiplying it on both sides of the equation. All right, so hopefully you found this video helpful.